Hi guys, and welcome to this video on substituting and evaluating. The next video in the series on algebra at a year 7 level, but useful probably for year 8 as well because it's repetitive algebra and it is incredibly important. Now remember, algebra is nothing more than a big fat trick. Let's get that on the table. When we see through all these ridiculous tricks that we use in mathematics, then actually you will be a gun with a little bit of practice. Don't forget, practice makes perfect. Apparently, so my parents say. Now, if you haven't already done so, welcome and thank you very much. There is a little doohickey in the corner that will allow you to subscribe to my YouTube channel, which is really, really important. Alternatively, head over to maffsguru.com if you're not already there, maffsguru.com, where you can search for videos and you can do all sorts of interesting stuff. There are notes to download and everything. Yes, the notes I'm about to write all over and the stuff behind me is downloadable on maffsguru.com. All right, let's kick in. Now, as I always do, I like to start with a little bit of an introduction and let us know what it is we're going to learn. We're going to need to know by the end of this lesson what it means to substitute, to evaluate. Now, in my previous video, actually, we already did the stuff on evaluate. Evaluate. It's finding the value of something. Know that a pronumeral really just stands in place for a number, what it is, a pronumeral actually is, and how to use BIDMAS. And I say there all the time that maths is a big fat trick. So zooming in a little bit more to give me some room. During the last lesson, we spent time looking at the language of algebra. And as I say, if you haven't already watched the video, head over to maffsguru.com. You can load it up. It's just there as the title of the Introduction to Algebra. And you can watch that to give you the context of what we're about to do. All right, but we looked at the differences between expressions and equations and all of those important words like terms, coefficients, variables, pronumerals, and constants, which we're going to use for the rest of this particular course. Now, I don't know about you. Are you a footy or soccer lover? Now, if you're in the UK watching this, you're probably going to turn around to me and say, well, what's the difference? Ah, well, I'm in Australia. Yes. And over here, footy is Australian Rules Football, AFL, which is actually quite interesting to watch. Sorry, guys, if you are a ardent soccer supporter. Yeah, don't really get it myself. A lot of overgrown men with fabulous hairstyles running around just for glory, whereas footy, AFL, I think is far, far more interesting and a nicer environment when you go and watch the games. Anyway, which do you prefer, footy or soccer? I don't care. I really don't care. So sorry, don't care. The point of it is, each of those sports have something that is important in mathematics. In fact, they stole it from mathematics. That's what I'm suggesting. Why? Because they use the word substitute. And we've been using that for many, many, many years. What does substitute mean in maths? What does it mean in footy? What does it mean in soccer? It means you take a player off and put somebody of equal value, you hope, in their place. And that's what substitution is. Now, why would you substitute in soccer? Well, as I say, they're injured, they're a bit tired, their hair's fallen out of place, lol. Anyway, substituting is so, so important. Take something out of an equation or off the field and put something of equal value in its place. Okay, so letters are just in the dinner queue for numbers. Yes, when you are in that queue, and then basically, hopefully you're going to get served first, and then the next person in the queue, and the next person in the queue. And in mathematics, order is really, really important. All right, so a list of terms, as I say here, is nothing more than a load of things in a queue. Right, a pronumeral is a variable. Let's have a look at this here. So we've got something like 3x. Let's imagine x, let's choose a different one because x's are like xylophones. Let's say 3a. What do you reckon the letter A could stand for? Let's start thinking about stuff that an A could stand for. Let's say apple. So hopefully we are now reading this as 3 apples. Well, the question I have here is, well, how much is an apple? Well, pretty much depends on where you go, doesn't it? If you go to Coles, you might pay $1 an apple. If you go to Woolies, you might pay $2 an apple. If you go to somewhere really expensive, Harrods in the United Kingdom, you might pay $5 per apple. And so what I'm trying to say here is that the value of A could change. It could be $1, for example. It could be $2. It could be $5 for an apple. This will change how much I pay in total. So that A just stands for the cost of an apple, for example. And if we remember that with maths for all of the letters we're going to use, that they're effectively probably standing for a number, then you're going to ace this algebra stuff again. Now the point of algebra is, if I decide in one question the value of A is going to be 5, for example, then for that whole question, or that whole part of a question, the value of A will stay as 5. But as soon as I move to another question, I might decide to use the letter A again, but the value could be different. And that's a bit of a trick for the maths, is to remember that for every single question, the value of A or B or C or whatever letter we use can actually change. Now again, as usual, it's great to use some examples provided by the Cambridge Essential Textbook Series. Thank you so much, Cambridge. And what we're going to do here is look at, oh, hold on, there's a red word. We have the word evaluate. What does the word evaluate mean? Evaluate. This means I'm actually going to end up with a physical answer to a question, an actual numerical answer to a question, a number. Later questions in this exercise or in this topic, we won't necessarily end up with a number, a final number. We'll end up with a collection of terms. We'll have groups of things together that we can't actually make simpler. But I don't want to rush things. This is the nice and easy stuff. So it says, given that t equals 5. Okay, thank you very much. T equals 5. Evaluate t plus 7. So here we go. This is my first question. T plus 7. What it's saying is, write out. Now, I always write down t plus 7. I write the question down first, and then I'm going to put an equal sign here. So, formula. I'm going to write down the formula of the thing. And then I'm going to substitute. So I'm going to take out, it says, well, t is 5. So where the t is, I'm going to write the 5, and then copy down the rest. And now I can actually find a value to this. I know that 5 plus 7, when I went to school, and you could argue I'm still there, is actually 12. So I've now evaluated t plus 7. For that one example where t equals 5, I get 12. What about the next example? Well, it says 8t. So what is between the 8 and the t that we can't see? It means kissy kissy. So I always say, well, let's write that out. Let's do this over here. 8t is equal to, oh no, work down the page. Now, algebra actually always works down the page. We never work across in algebra, it's way too complicated. So 8 times t, so there's my formula. And now I'm going to substitute, as in take the value, or t equals 5. So where I see a t, I'm going to write the value 5. All right, that is a 5, not an s. And now solve or evaluate. So 8 times 5, again, when I went to school, was 40. And I've done that. I've evaluated. I've got a value. Oh, getting harder. What have I got here now? I've got 10 over t. Now, 10 on top of the t, what does that mean? It's the divide sign. Plus 4 minus t. Okay, you are not going to trick me. I'm going to write you out first, because I always write out the question first to make it easier. Then I'm going to write an equal sign. And now everywhere I see a t, I'm going to put that value of 5. So 10 over 5. Plus 4 minus 5. Now, it's really important here that we do BIDMAS, or BODMAS as you may know it now. Again, we'll come back to that in just a moment. But brackets, none. Indices, or over of. Yep, there we go. So we have an over of. I don't really like that. I'm going to ignore that. I'm going to deal with BIDMAS. Brackets, indices, division. Is there a division? I should cocoa. There is 10 divided by 5, which again, when I went to school, was 2. Now, I don't worry about sorting anything else out. You'll notice I just write it down as it is. And now I go back to BIDMAS. Brackets, no. Indices, no. Division, no. Multiplication, no. And addition and subtraction, which are effectively level, I can do. So 2 plus 4, 6 minus 5 gives me 1. And again, if you do this, if you write the formula or the question out, substitute and solve it using BIDMAS, you cannot make a mistake in this stuff. You will be geniuses. Now, again, I'm going to come back here with this whole BIDMAS, BODMAS stuff. I don't totally understand BODMAS. I do not understand and have never understood what this over/of is. If you do know and can explain it to me to get me to change my mind from BIDMAS, leave a comment below and I will do what I can to listen and, wow, you never know, you might change my mind. But at this moment in time, I actually think that brackets, indices, and what is an indice? It's a floaty number. What's a floaty number? It is a number what floats. So for example, if I had t with a little floaty 2, that floaty 2 there is, in my view, called an index. This little thing here, what floats, is called an index. All right? I can't call it brackets, floaty numbers, division, multiplication, because it doesn't make any sense. So I'm always going to use BIDMAS. Let's see, what are these examples of how to use BIDMAS? Right, we know this. So if, for example, I had 2 plus 5, well, that's really stupidly simple. That's just 7. But what about if I had 2 plus 5 minus 6, for example. Now, in this situation, when we use BIDMAS, we've got B brackets first. So we must make sure that we use our brackets first. And because my brackets tell me to do 2 plus 5, I do that first. I write an equals, and I go 7, and then minus 6. And in my head, I always go through it again. Brackets, no. Indices, no. Division, no. Multiplication, no. And so I can do my subtraction, which gives me 1. Easy peasy lemon squeezy, yes? Happy so far. Right, let's come up with another example. What about 3 minus 4 in brackets? We'll put a 2 outside there, plus 7. All right, same thing. We've got some brackets in there. So BIDMAS tells me to start with my brackets. I'm going to put an equal sign, and I'm going to say that the brackets, 3 minus 4 in this situation, is negative 1. Now, here's an interesting question. What is between the 2 and the bracket? Well, when a number and a letter are stuck together, there is a kissy kissy. And when there is a number in front of the bracket, there is also a kissy kissy. So I now rewrite my question as 2 multiplied by negative 1 plus 7. Now, using negative numbers here was a bit evil, in fact, in a year 7 video. But if we've got minus 1 and I've got 2 lots of them, oh, lots of, there's that word, then I know that I will end up with a minus 2 plus 7. And I know that using mathematics, that if it's minus 2, which is pretty much what it is in this room at the moment that I'm recording in because I'm freezing cold, I can't even feel my fingers. Minus 2, cold, plus 7, move it up, move it up, move it up, and I'm going to end up with 5. Now, as a bit of a shortcut, shouldn't really do this, if I have lots of things that have just got pluses and minuses together, I can actually change the order. So I could have thought of that as plus 7 minus 2, which is also 5, but negative numbers we'll come back to later on. You see what's happening with this BIDMAS stuff? Let's come up with another example. 4 plus 7 divided by 3 plus 6. Now this is going to be a disgusting question, so let's actually make that 4 plus 8 to make it nice and easy. Right, what do we do here? Brackets. There aren't any indices, there aren't any division. There is, but we have an interesting problem. You are only allowed to divide when there is one number on the top and one number on the bottom. Is there one number on the top? No, there isn't, but there is something I can actually work out. So 4 plus 8 when I went to school was 12. Write down everything that you've not used. Now, a lot of you, and I'm going to say boys, will try and do this all in your head, and that's a real shame because this is where you tend to make mistakes in algebra. It's not that you can't do the work, you just make silly mistakes. So do it line by line. Rather do one more line of working, that extra 5 seconds of working out to get all the marks and lots of ticks than to waste marks. So let's scroll up a little bit. What have we got here? So can I work out? We go back to the BIDMAS stuff. Brackets, none. Indices, none. Division, oh, I should cocoa, there is a division. And it says 12 divided by 3. How many 3s are in 12? 4. And I'm going to add on 6. And again, we know that that just gives us 10. So this BIDMAS stuff, really, really important. Now, I've already talked about this formula, substitute, and solve stuff. And it's weird that in my current school, people walk past me and go, I know, and they're 18 years of age. It's a little bit weird, really. But I use the whole thing to say, write down the formula. Now, the word formula, I always say question, but sounds stupid. So formula, substitute, solve, write down the question, substitute it in, and then solve it, and you are a gun. So let's try and put it into practice with some examples from the Cambridge Essentials textbook series. We love Cambridge. Now in this situation it says substitute, so take out the letter and put a number in its place. So substitute, but they're giving me 2 things to substitute. A little bit harder, but the math isn't any different. X equals 4 and Y equals 7 into each of these expressions. What's an expression? Something without an equal sign in it. Right, so we've got 5x plus Y plus 8, but my equal sign because we work down the page. And do we know what what's between the 5 and the x? Numbers and letters stuck together have kissy kisses, and I always write those in to help me so I don't make a mistake. Rightio, so let's see. So we are now going to substitute. What is the value of x? It is 4, so it becomes 5 times 4 plus. What's y? 7 plus 8. Okie dokie. Right, now, can we work any of this out? Brackets, there aren't any. Indices, there aren't any. division, there isn't any. Multiplication, there actually is. Do you see that? There is a multiplication, so I always do that bit first. 5 times 4 is 20, and I'm going to just write plus 7, plus 8, and can I work that out? I should hope so, which gives me a great value of 35. There we go. Easy. Formula, we'll write the question down, put in the kissy kisses, substitute, and solve. What about this one here? Oh, let's keep the values in there, Maths Guru. 80 minus, and some brackets, 2xy plus y. Oh, they're trying to confuse us. We've got a 2xy. Remember, that's the same as 2 kissy kissy x kissy kissy y, or just 2 times x times y. So I'm going to write that out so I don't get confused. 2 times x times y plus the value of y. There we go. I've written the question in with all my kissy kisses. Now we're going to substitute the values. I've got 2 times x we know is 4, y we know is 7, plus y. Oh, hold on a moment. We know that y is 7, remember? When y is given as 7 in a question, it's 7 all the way through that question. So, BIDMAS, brackets. Well, there are brackets, but the brackets has got stuff inside that I also need to simplify. And as it turns out, I'm now going to do my multiplication first. I'm going to do this 2 times 4 times 7 first. I'm going to write down the rest of the question. There's 80 minus, let's put the brackets in. There's the plus 7 because I'm not using it. So 2 times 4 is 8. 8 times 7 is 56. There we go. So 56. Now I'm going to run out of room, so let's rub that out so that I can continue working down the page with enough room. So brackets, yes, I've got something in my brackets I can now solve. 56 plus 7 gives me, so that's going to be equals 80. What's 56 plus 7? 56, 57, 58, 59, 60, 61, 62, 63. Minus 63, yes, I did use my fingers. Nothing wrong with using my fingers, at least I didn't grab my calculator. And finally, 80 minus 63 gives me the wonderful value of 17. And there we go. Formula, substitute, and solve. Final example, getting some little floaty numbers in now. I suppose the first thing we need to do is make sure we realize what a floaty number is. When I have a floaty number, for example, p squared, that means take the p and multiply it by itself. So when we square something, we have that floaty 2, it means take it and multiply it by itself. So if I had 2 squared, for example, that would be the same as 2 times 2, which would be 4. Yeah? Okay, brilliant. So 3p squared, it says, if p equals 4 and t equals 5, find the value of. Okie dokie, we can do that. Right. So first thing we need to do is write the question out, and you're going to say, but they've already got the question out. Why are you writing out again? Because later on in maths, writing this stuff out is going to give you marks. Believe it or not, it's going to give you marks. Better to get it right now and be brilliant than not. So, 3. What's between the 3 and the p? A kissy kissy. What does p squared mean? P times p. So I'm writing it out as 3 kissy kissy p. And still come back to the kissy kissy. Do I know what the value of p is? I do. I'm going to substitute now. 3 times 4 times 4. And what does that give me? 3 times 4 is 4, 8, 12. And 4 12s are 12, 24, 48. And there we go. So 3p squared, 48. Oh, hold on a moment. We're getting a bit more complicated. I'm not going to move that off because I need to keep the question in there. What on earth do you think p with a floaty 3 means? Well, if a p with a floaty 2 meant p times p, what do you reckon a p with a floaty 3 means? Oh, yes. It means p, kissy kissy p, kissy kissy p. Ooh. Right, so let's see. We got t squared. So let's write this out first. So t squared plus p cubed. So we need to write this out as t kissy kissy t plus p kissy kissy p kissy kissy p. All right. We've written the question out. We've got the kissy kisses in. We're now going to substitute. Well, it says let t be the value of 5. So that's 5 times 5 plus 4 times 4 times 4. All right, so BIDMAS, brackets, none, indices, none, division, none, multiplication, yes. There's 2 multiplications to do. So I'm going to write down the plus in between to make it easy for me. Let's write it so that it doesn't look like a plus with an equal sign. So there's my plus. 5 times 5, 25. 4 times 4 times 4, well, 4 times 4 is 16, times that by 4 is 64. And adding those together gives me the great value of 89. One more. Square root of p squared plus 3 squared. Well, we're going to scroll up a moment Because what on earth does that mean? Well, the square root we'll come back to in a moment, but that's now p, kissy kissy p, plus 3, kissy kissy 3. Righty-ho. So we've written it out in a way that we can do. We've done that square root sign. I'll come back to that in a moment. Let's leave it in there. Do I know what the value of p was? Yes, it is. It's 4, kissy kissy 4, plus 3, kissy kissy 3. Let's work out what 4 times 4 and 3 times 3 are. 4 times 4 is 16. 3 times 3 is 9. Keep that square root sign in. Keep the square root sign in is 25. And now, some of you will already know this, and I'm just going to move this up here so I've got a bit of room. When you square root a number, you are trying to find a number that when multiplied by itself gives you 25. Now, what does that mean? So a number times itself gives me 25. 5! 5, because 5 times 5 is 25. Now, obviously, we're getting a little bit harder. Finally, one last harder example, and again, it just comes back to the division I talked about in a moment ago. We've got 6 brackets 3x minus 8 divided by x plus 2. Right, we've written the question out. So it's 6 kissy kissy 3 times x minus 8 divided by x plus 2. Do they give me the value of x in the question? They do. Let's say let x equals 5. So I've written it out. I've got my kissy kisses in. Let's put in my numbers. 6. Now actually I'm going to put in a kissy kissy between the number and the bracket because we know that's there as well. 3 kissy kissy 5 minus 8 divided by x, which is 5 plus 2. Now, brackets. There are brackets, so we have to do the brackets bit first, and we've got that multiplication. So it's going to become 6 kissy kissy. 3 times 5 is 15, minus the 8, divided by, and I'm just going to leave the rest at the moment. Yes, I could work it out, but I don't want to confuse myself. So we're going to go back up here and carry on my working out. Go back. Brackets. Are there any brackets? Yes, there are, but we can now work out what's inside the brackets. So we get 6 kissy kissy. What's 15 minus 8? 7. All right, so we don't need the brackets anymore. Divided by 5 plus 2. Okay, brackets, no. Indices, no. Division, yes. But we can't divide unless there's one number on the top and one number on the bottom. Oy, this is challengingly exciting. But what I can do now is use my maths knowledge to go 6 times 7 is 42. And I can do that 5 plus 2 gives me 7. And lo and behold, what is 42 now divided by 7? It is, in fact, 6. And there we go. Now, ladies and gentlemen, there was a lot of content here. This is quite a long video, but it's quite important to know how to be able to substitute and evaluate. Substitute, take out a letter, put a number in its place, and use BIDMAS or BODMAS to help you work out. All right, I'm done. Thank you very much. Maths Guru signing out. If you haven't already done so, do me a favor and subscribe by clicking at that little doohickey and heading over to mathsguru.com if you're not already there watching this video. Really good to see you. Hopefully we'll look forward to seeing you in the next video. Take care. Have a good day. Maths Guru signing off.